everyone. Thank you for coming tonight, and thank you to our panellists for coming as well on a Monday evening. I'm hoping you guys will learn a little bit about signalling engineering today. So our three panellists are from Egis and Axiona, working on a couple of different projects, and I'm sure we'll hear more about them soon. But Nguyen, our president at SME, and I don't know your other positions.
Yeah, well, I'll talk a bit about our hosts for tonight. This event was organised as a collaborative event between SME, the Society of Monash Electrical Engineers, the Transport Engineers at Monash, and Monash Railway Express. So I'll let you know all about what each of those groups are. They're all student-run, student-led groups at Monash. So SME, the Society of Monash Electrical Engineers, represents the Electrical and Computer Systems Engineering cohort at Monash. One of the oldest clubs on campus, and it covers the cohort's needs from across careers, technical, academic, and social. So we have events essentially weekly. Among those are our industry events. So this signalling panel is part of SME's Industry Pathways panel events, which will be happening throughout the year. So there will be future panel events covering different sectors within related to electrical engineering, as well as other aspects of careers, such as women in engineering and so on. There's also a Tech Industry Night Careers Fair coming up in 2 weeks, also on Monday at the same time. So look forward to seeing you all there as well. The Transport Engineers at Monash is focused on transport engineers, as well as engineers in adjacent sectors and in transportation more broadly as well. So its flagship event is the Industry Mentoring Program for Transport Engineers. It also runs other industry-related events throughout the year as well, including site visits and also opportunities to go to conferences and scholarships through links with the Institute of Transportation Engineers and the Transport Professionals Association. And MREX, Monash Railway Express, is Monash University's newest engineering student team. Founded just over a year ago. Goal of that team is to build a 1/5 scale locomotive to compete in the IMECI Railway Challenge. So last year, MREX entered the entry-level competition and came second place across all the teams across the world, and is now building a locomotive to send over to the UK mid this year to compete there and hopefully win that challenge as well. So MREX already has the locomotive, is currently being built close to completion. So if you're ever coming by Makerspace, you can see the locomotive at the front of Makerspace. And there's also, on Saturday actually, there was a test day. So the first time that the train hit the tracks. So this video is from Saturday, and you can see the loco will eventually take off. There we go. Oh. Let's come back. Keep going. There we go. So it works, which is a great first step. So we're pretty confident that it will do very well over in the UK in the end of June. So pass back to Seth.
Thanks, Nguyen. Hopefully people will filter through quietly after we begin. I know that some classes are just a box that can be a bit tight getting from other ends of campus, but I'll invite panellists to come take a seat as well. So the way this is going to work, I've got some pre-prepared questions that I'm going to ask our panellists, and then I'll pass the floor to you guys where you can ask anything that you might want to know about your future career in signalling. So can I just ask you guys to briefly introduce yourselves, where you are in your career, and what your current role is?
I'll start. My name is Jennifer. So I studied at Monash. I did electrical engineering. I'm now a signalling design engineer. I've been doing this for 6 years. Started out as a grad and been here. I've worked in Victorian projects. Worked in a lot of concept design in regional rail. So that's B-Line, ARTC. Now I'm currently working on circuit design in Queensland or Brisbane projects, which is the Cross River Rail project, if you guys have heard of that. Yeah, that's pretty much me.
Thank you.
Cool. My name's Culum Bennington, so I'm a signalling project manager with Metro Trains working on the Southern Program Alliance. So we're looking after level crossing removals along the Frankston line and Werribee lines at the moment, and also doing some stuff for Sunshine Super Hub, which I think is about to be recalled the Melbourne Airport Rail, stage 1 or 2 or whatever it is this time. So I've been in signalling for about 16 years now. Started off, I did robotic engineering at Deakin University. And then branched my way into signalling through there. So I look after all aspects of signalling project management and things like that. So from design or concept through to design to construction and then commissioning. So that's where I'm at the moment.
My name's Neil. I work for Egis, Egis Group in Melbourne. I have, where are we? 2026. I have 21 years of experience in signalling. My job title at the moment is Principals Design Engineer, which means I get to do the really interesting stuff. I didn't actually know that signalling was a thing. You know, when I was a kid, or when I was going out on the language on the P1SS, I would always jump on the train and magically appear in the middle of the city and have a good night, and know I'd get home reasonably safely. The only reason I got into signalling was because I needed a job. I decided to go for an apprenticeship rather than go the university route. I got an apprenticeship as an electrician, and then from there I got a job as a junior designer with another organisation, and here I am today. It's a pathway that isn't very well travelled anymore, and the changing landscape of the business rules means that fewer people will be able to accomplish it. Yeah, that's about me.
Great, thank you. So I'll move on to our first question. Jennifer, I'll start with you. Why did you choose to go into signalling engineering? Was it during uni or was it after uni that you decided to go into this pathway?
I never decided it was what I could get at the time. So I actually applied for a graduate position, you know, as you do when you're in your final year at around this time. And I got a call from Oricon, and they asked me to go for their group interviews. And I had 2 teams call. It was a transport team and a buildings team, which were my 2 top options. And when I got to the interview, my name was on 2 tables. So I was like, okay, where do I go? And I just sat on one of the tables, and it just happened to be the transport table. And yeah, that's how I started into signalling. I had no idea what it was. We never learned it in university, and I think at first it was very confusing. They call it the dark arts of transport, I guess. I've just been here. It's been great. I think if you're looking for something that is, at least in design, something that is not like you're always stimulated. There's always learning to do, but it's not super crazy or intense. It's a perfect balance for me. I have a life, I have a personal life, like a work-life balance, and I've just stuck to it. There's so many pathways to go in signalling. There's so many areas of specialisation that you can do. So that's been my journey so far.
Similarly, I fell into signalling after uni. So straight after uni, I went and worked for a TV manufacturer in the service and development team, and then by chance was fed up with that job and actually just went and spoke to my mate who was working for a signalling contractor at the time, and then got into signalling that way. So again, similarly, it's not something you really think of at uni, but these days there's a lot more work and a lot more pathways to actually get into transport and signalling especially. So yeah, it's just one of those things, and it's probably a similar experience with a lot of people. In my team, there's a lot of people that have gone through as civil engineers and then come into signalling and learnt the different elements through that, as well as electrical engineers and things like that. So we generally take a lot of different people and a lot of different skill sets, because it is very varied as you go through. So from signalling, you can deal with the circuits, you can go through to construction, you can deal with mechanical, you can do all those different elements. So it's not just an electrical field, it is very broad when it comes to that. And even from data writing and things like that, from once you get into train control and computer-based interlocking. So yeah, that's something I fell into, and I love it because it's very varied.
I don't really have much to add other than what Culum said is it is immensely varied. You can be working on electrical diagrams one day, you can be working on completely logical diagrams the next day. We have what we call control tables, which describe how the designer intends a signalling system to work, and that's basically the system is keeping people safe, keeping trains safe, keeping road users safe where there's level crossing. Control tables describe all the requirements around what is required for safe movement of trains. A guy from Queensland to me once said to me, the operators are nuts. You could just have like a crane dropping trains on the tracks. They would just run trains all day, every day, one every 2 minutes if they could. So our job as signalling engineers, or at least in the design perspective, is to try and the operations team what they want in flexibility whilst maintaining the safety of the system. I think that's where the real art is. It's like trying to find ways to keep the system safe while meeting these targets for train movements.
Yeah, cool. So it sounds like signalling chose you guys rather than you choosing signalling, which, I mean, hopefully this panel can give people the opportunity to choose signalling, but maybe that'll be the case for a lot of people after uni as well. So my next question revolves around what you would do if you could go back in time. So are there any important skills that you have gained over your career time that you wish you could have refined sooner, maybe in uni, maybe earlier, maybe at your early career point? And maybe we'll do the reverse order this time, so we'll start with Neil.
Well, seeing as I didn't really do uni, I did for a year, and it was fun. I think the biggest thing actually is to just keep learning. You know, we've said the dark arts, we've said it a very varied industry, but you just got to keep learning. If you don't keep reading and you don't keep researching, then you fall behind, and someone will say something, and you're like, oh, I didn't know that. And then it can put you back a little bit by not being up there. And I know it sounds like a really staid and cliched thing to say, but when you get to age, which is just shy of 100, you'll actually realise that learning is quite enjoyable.
My one's probably something that one of the lecturers told me when I was at uni, and that's a lot of engineers, while you'll start off designing things and building things and all that kind of stuff, the one skill set that's across the board, whether you're just starting off as an engineer or you get through to my role or higher, is management. And that's both personal management as well as project management. So one thing the lecturer told me was that 80% of the class that I was in at the time will end up in a management position. And for me and a lot of my mates that I went to uni with, that's definitely come true. But it doesn't just extend to a management role. It's going through and being able to manage your time, being able to manage a project that you're working on, the workload and all that kind of stuff. And it's something that if I went back, I'd probably focus a little bit more on that, because that's what can help you, one, if you want to progress, but it can also make you more efficient at your role and your job. So that way you can plan and basically process everything in the right time manner. And I've learned over the last 16 years what to try and do and what not to do. I've definitely learned what not to do by doing it wrong. But yeah, if you can focus on that a lot of the time, and not just from a management perspective, it does help out.
So for me, in terms of the technical space, I would say if you guys are electrical engineers, try to get your foundations right. The kind of, like, I've been to Monash and you do learn very technical things, and it all comes, it's not really, I wouldn't say it's completely relevant. It's just the, as you guys are talking about, first principles that you kind of would like to know and understand a bit before you get to the job. But also don't be intimidated, because you learn everything on the job. And as long as you've got a supportive team, which is a really important thing, is to have people who are willing to teach and people who are willing to share knowledge. That's good. The other thing is I would try to keep in contact with your fellow your peers, yeah, because it's likely that a percentage of you guys will end up in the same industry, and even though you may just be, you know, like what's it called? You don't speak to them very well, or you don't really know them that much. I think it's good to keep that connection because that runs long term as well. And I think translate that or follow that through the rest of your career. When you go into an industry, you'll meet people, and it's good to network. It's good to have that those connections. For me, especially as like a woman in engineering, it's very hard to come across females, and having a tight-knit group of females that you can talk to, that you can come to for advice is really important. Like, I feel like that's what's kept me in engineering, to be honest. So yeah, it's just the network and the friendships you obtain. Keep them as much as possible.
Yeah, great. That's a good message, I suppose. Keep everyone close by. Yeah. Okay. So after this, what are some things that you would recommend to specifically electrical engineering students that would prepare them for a pathway in signalling engineering? Might have kind of answered it already, but anything more technical that might be of assistance?
I think from my perspective, I did robotic engineering at uni, so there's a lot of autonomous systems and mechatronics and everything like that. So from my perspective, signalling is a lot of different pieces put together to make a whole system work. So from my perspective, from technical, that's probably the best thing that I've been able to do and understand, because you can bring those pieces together and actually troubleshoot from there. So from my perspective, those different systems are particularly moving forward into what the signalling will be into the future. Because I deal mostly with traditional signalling, which is where you see the signals on the side of the tracks, and that's how the drivers get the information. But the new systems are all going to be basically computer-based and driverless trains and things like that. So they're going to become autonomous systems. So understanding that part of it, if you want to focus on signalling, is going to be a good one, particularly if you like writing code, because data designers are going to be in hot supply at one point once you go down that path, and more of the systems go that way, because we still do it now, but the traditional side, like Neil was talking about with the circuits, is a dark art in its own way, but then data and then the control systems is definitely a big dark art going into the future.
What was the question?
Is there anything that you'd recommend on the more technical side to focus on?
Definitely, point on what Culum says, understanding how different systems will communicate, because we have, there's so many disparate systems out there. Even in the metropolitan network within Melbourne, we have a mechanical interlocking which interfaces to a relay interlocking, and everyone knows what a relay is. If you don't understand how relays work, that's a really good tip there, because there will always be relays. I know that sounds really lowbrow, but the amount of students I've had trying to tell me that, the relay is just like an automotive relay, and it's really not. Yes, the automotive relay, understand different types of relays, but the control systems within, say, Metro, where the majority of the control is performed on the network, is using a different protocol to the systems that are in the field, and there's probably 7 different interlocking types out in the field. So if you can really master the art of protocol conversion and having a front-end processor to do the conversion, and foresee any issues with the bits coming in from the field, bits going out of the field, that will be good if data's your thing. Data's not my thing. It wasn't in 1995, and it's still not today.
Yeah, I work with a lot of circuits and hardware design. I would say you do deal with power, so you will deal with power. Besides data, that's like coding, that's Boolean logic, I think. Power, there's a bit of comms. You can delve into that. What else?
There's a really big one actually that I just thought of. Now you said comms. Cyber security. Maybe not necessarily electrical field in its own right, but cybersecurity is really blowing up with the introduction of ETCS, the European Train Control System, and the new CBTC, Communications Control System, on the Shineton, Pakenham and Cranbourne lines. They're all open Wi-Fi system. Well, the CBTC is a Wi-Fi system, so cybersecurity is absolutely a going concern and will be well into the future.
Yeah. Okay. That's definitely an interesting fact that it's a Wi-Fi system.
Well, the CBTC is the ETCS.
Cool. Okay. What have you found is unique about signalling engineering that you would say is unique to signalling engineering and not any other field?
Oh, geez, the amount of standards. So, oh my goodness. So there's the AS standards, the Australian standards, which kind of overarch everything in Australia. But then in Victoria, you have a different signalling principles, and then you've got your jurisdiction, you've got your MCMs, your B lines, and your ASCPs. They have their ways of doing things, they have their own sets of standards. And then I'm now working on Queensland, so you have QR standards, and that's a whole different thing. So actually, on that note, I think it's good to kind of know bits and pieces of everything in different jurisdictions, different countries, different states. It just helps because, you know, like if you have experience in MTM, but there's a project in Queensland or something, it's similar, but not exactly the same. There's new things you have to learn. There's a new way of signaling. So yeah, I think just the amount of standards that go through.
Just the pictures are all different on the designs.
Yeah.
So, between Queensland, New South Wales, Western Australia, Victoria, the way to show a signal, so you've probably all seen what we call the traffic lights for trains. They're all shown differently on every different state's drawings as to the way they go, to the way they do it, and that's represented across the different gauges of rail across Australia as well. So it's very unique. Each state's unique, each operator's unique, and yeah, it's great fun.
To be honest, when you said what is the unique thing about signalling, definitely the people.
Yeah, that's a good one.
The people are, there are a lot of very intelligent people in signalling. The people I've had as mentors absolutely confound me with what they know, how they understand just concepts. I wish I had their intelligence, but yeah, I think very valid point. I can't really add any value to that.
Definitely links into the you're always learning aspect of your career paths. Yeah, it's a lot to handle, I'd imagine, if you're working across multiple states.
Even just within Metro itself and dealing with the stuff that we deal with, you deal with, from signalling perspective, you deal with every other discipline that's in rail. So for your signalling design, you deal with track to get your grades and all that kind of stuff and curves. Electrical, you get the power from the HV power. You get comms from the comms team. You deal with overheads because they get in the way of your signals and everything like that. So you literally touch every other discipline that's within transport effectively because you're dealing with ops and everyone. So that's probably the big unique. Like if you go and become a track engineer, you're dealing with just track and dirt and things like that. Signalling, you're dealing with every other discipline. So you got to call what I call it herd the cats when you're going through and trying to get it all sorted.
So coordinating how everything fits in together.
Correct.
Yeah.
The only other thing I would add is that there's only so many ways you can keep trains, people, public safe. You know, we have what we call principles, which is basically let's not have our trains meet at the same time, in the same place and space. So every operator has a different risk appetite. Some will absolutely don't care about risk because they might run 3 trains a day on the train line. So for them, they're happy to book out part of the track for you to do some work between trains. Someone like MTM, if you don't apply 15 weeks in advance with a nice letter that's signed off with please regards, then probably won't get on track. So whilst the principles may be very similar, the implementation of it is very different.
Interesting.
And so you have to do your research because you don't want to make yourself look fool in front of the operator.
I guess I can throw a project off a fair whack as well.
Yeah.
Yeah. So some people in this room might have signed up not knowing what a signalling engineer actually does, or have never even heard of it before. So if you were talking to someone who had absolutely no idea what a signalling engineer is, how would you describe that? It's a bit of a heavy question.
How I learned about it, or how I think of it, Grant, is when you're on the train, this is just traditional conventional signalling, which is what most lines currently have, except for the metro tunnel. We have the signals, so you guys will see, I think it was two signals, 2 lights. Those are basically the traffic lights for trains, and then they connect to the tracks, and there's this whole control system. So things that detect the train, the presence and the absence of trains, things that train detection, there's train protection, so things that stop trains in case they go over speed or in case they run red lights. And there's a whole electrical system within the rail network. It's not just the rail and the train itself. And so the whole point of that, as Neil said, was to have safety, to ensure trains don't collide with each other. And so there's hardware stuff, there's things that are on the track, so lights, different types of equipment, and then they connect to electrical boxes. So you'll see like signal boxes if you go to the station, you might see different signal boxes around. So that's where all the wiring and all the stuff that I deal with is at. And then that connects to the brain of the whole system, which is the interlocking. We mostly have computer-based interlocking, which is where your data comes in. And then there's also other older school types of interlocking, like geographical interlocking and relay interlocking. And that's a signaling system in my head. That's what you deal with. So there's different types that you deal with.
Yeah, nice overview.
I guess, from my point of view, as Jen said, it's a whole series of interconnected systems. As a signalling engineer, you could be asked to work on any one of those systems, unless you work for Siemens. And then if you're a bonding plan designer, you design bonding plans. If you're a control table designer, you design control tables. But that has its merits as well, because then you become a specialist in one particular area. My design life wasn't so implemented. I got to work on a whole heap of different things very early on in my career. The problem is when you work for a smaller company is that you don't really get the time to read the standards, of which there are many. So your design lead will say, do this, you do that, and then your comments come back and it's like, can't do that. So yeah, it's a whole heap of interconnected systems which you have a responsibility for to make sure it's going to perform in a safe manner. It's not the checker's role to make sure it performs in a safe manner. It's not the IV's role to make sure. As a junior designer, yes, you will be allowed to make mistakes and say, oh, you can't do that because you need to backprove a relay or whatever particular principle we're trying to enforce. And that's because you haven't been exposed to those concepts yet. But later on, as a designer, you are responsible for ensuring that the system will be safe. It's your name that goes on the drawing. So you'll be saying this is safe to run trains.
Yeah, so just to clarify, in case you guys don't know, in signalling there's
Sorry,
the
it's your
design that
knowledge.
the circuits and stuff that you create, and then it goes through a checking process, which is where a more senior engineer would check your work, and then it gets approved by an approver, which is kind of like a bigger guy as well. And then so that's design in general. After design, you go into the construction phase, like testing and commissioning. So that's where you'll have site, and you guys, it's up to you what you like to do. So if you like design, it's more of an office-based position. But if you do like being on site, there's also the testing and commissioning, which is where you get the designer circuits. And I can't speak to this much because I haven't done testing, but you test all the cables and all the wires. And so that's the construction portion of it. And once that's all done, there's also kind of the operations bit, which is where trains run, you have to make sure it runs on time and stuff. And then there's also the maintenance bit, you know, like you guys have probably experienced a lot of delays on the line. Sometimes track circuits and signaling equipment, they fail, and that's where the maintenance team comes in and fixes that. That's kind of like the life cycle of signaling rail.
Yeah, I had one of my junior engineers ask me one time I asked him where he wanted to go in signaling. He says, I wanted to do everything. And the thing with signaling, you can't do everything. So there is design, there's construction, testing, commissioning, and that can vary from just going out there and being a site engineer to go through and get the guys on site and make sure they can build what they need to build. Or you can then go through and then work up to a project engineer where you can go through and basically be in charge of the different work groups and things like that to go and build. Then you can go to testing, commissioning, and so there's a lot of different elements. So it's all about what you would want to do and what you're best suited to. Because if you like building things, then the construction phase is definitely one of the big ones from there. If you like playing and tinkering with systems and making sure they work, testing, commissioning is probably the way to go. So far.
No fun.
As long as things don't blow up and don't hit, you're fine. I've seen plenty of fun things go on where things have blown up because someone's put the wrong wires and connected the black to the red the wrong way. But that's the whole idea of what we do and the way we go about it. So the system is designed to fail safe, and we need to design it, construct it, and commission it so that way you guys as the passengers don't get hit. So if you want to get into design, great. These guys are your designers and things like that go through and design the system. Then you get into the construction, you can go build it, whether you want to get on the tools yourself or you want to go through and actually manage the teams and the plans to get to that point. And then you get to go through and have fun with testing and commissioning. That's where you meet some really unique people in the testing and commissioning phase. So it's all about what you want. And that's what I said before. It's very varied in what you can and can't do within signaling. So it's open to a lot of different skill sets and a lot of different ways that you might want to go into the industry.
There is also one other element which hasn't been spoken on, which is the maintenance engineer. We like to think of them as sitting in metro with donuts and coffees and not actually doing much all day, but that's not quite the truth. Their responsibility is for the system to make sure that any renewals for life expired equipment are done on time, that there's a strategy in place to change over the obsolete equipment. The cable shouldn't stay in the ground for very long, maybe 10 years, 15 years, and it should get replaced before it becomes a point of failure. So there's a whole heap of work going on within the elements of the franchise, MTM or Quality Line, to make sure that the system continues running smoothly and the experience as few delays as possible. And that is, there's a whole swath of engineers in MTM doing just that.
Unless it's mechanical difference. It's been there since 1910.
And no one can maintain that.
No one can change it.
It's definitely interesting. Some things that don't expire, I suppose.
No, they don't, and it still works. It's just not as efficient as new interlocking and so forth. But that's what we deal with when we're trying to build. So, for instance, doing Sky Road in Cannonook, we had to deal with all the old systems down at Frankston, as well as not as old systems towards Carrum, and we basically ripped all of that stuff out. So, but if you get into that space of conventional signalling, you're going to have to interface into those systems. And that's what my next 2 months is going to be fun of out of import. So, yes, because that's a fun system. It's a very old system. Very old system.
Something to look forward to then.
Yeah, hopefully.
So I've got one last question, it's a bit more open-ended. Before I ask that, I'm going to say to everyone, think of some questions that you might have. If you're a bit shy and don't want to speak out loud, do you have Flux? I'm sure you're all familiar with that through your engineering studies, hopefully. If not, just scan the QR code and you can type in a question, it'll come up on my phone, and then I can ask it on your behalf. So, last question is more open-ended. What is your favourite project that you guys have worked on at any point in your career, and not necessarily in Australia, if you've worked overseas? Anything at all?
For me, if I may, probably when Regional Rail Link was underway, which is 2013, 2015, I was working on a package of work called Work Package B. Very, very imaginative, wasn't it? We had probably 50 designers, signalling designers on the job at any one time. We had a team of drafters who would actually draft the designs we were sketching out. And I think the highlight for me was that not only was it creating a new line out to Geelong, or elements of a new line out to Geelong, but the team was comprised of people from RCSA where I worked, a team of guys from MTM, there were people from an old company, C2CE, which is now Raptech. There's just so many different companies, but we all worked together to achieve one aim, which was to get the commissioning done. There was no real boundaries of, well, you can't talk to them, they're their own company or whatever. It's just everyone pitching in to do the work. We worked in an office where we had the civil guys, the overhead guys, everybody was in the same office. So if you had an issue, you could get up and walk across and say, this is. Rather than send an email and get an auto reply saying I'm on holidays and we'll be back in 2 weeks.
Nice. Definitely a lot of teamwork then.
My probably favourite project was my first one when I first came in as a graduate engineer and site engineer, and then probably the reason I enjoyed it so much was because I got to learn so much. So we did what we call a South Improvement Alliance. I like working on South projects apparently, which was upgrading the tracks between Seymour and Albury. And so that's basically where I built my foundation of signalling and my appreciation for signalling, and enjoyed it so much. So just those first steps to understand what a signal was, what the drawings were, what a track circuit was, that was probably my most favourite project, because I was probably naive at the time and probably had that innocence about me that this is all fun, building different things and commissioning different things, and I got to see the full life cycle of that project. Now I get to deal with all the politics of everything, with the decisions that are made through the government for different projects and stuff like that, so that's got its own challenges and fun. But my favourite one was just that first one where I got to meet some of the other graduates that were there at the time. So me and one of the other guys still catch up every now and then. And it was just a good foundation to be able to learn what signalling was, what rail was. And it was in the country, so that probably helped a little bit as well, because there wasn't the craziness of metro. But it did give me a good foundation in signalling and through that space. So that's probably my favourite. Yeah, AOTC is fun. There's no overheads to deal with.
Yeah, mine would actually be similar. So it was the first kind of projects that I worked on as a grad. I worked on a lot of concept design for regional rail. So I got to travel heaps during COVID. The traffic was amazing. got to go in a company car as a hybrid, which was the first time I drove a hybrid. I was like, oh, this is amazing. We got to go out and we were kind of assessing level crossings. So I hope you guys know what a level crossing is, but when road meets rail, we don't have too much of that here, but we have a few, I think. There are booms and lights that go off. In regional rail, sometimes you don't have them. Sometimes it's like access to a farm or something. So we were going with RPV at that time. We had a look at bunch of level crossings to see if they needed any upgrades, and if they did, what kind of level of upgrades. So if it was just a passive crossing with no lights, no booms, then you think about, okay, do we actually have to electrify the level crossing to have the lights and booms? Is it worth the government's money to do that? So a lot of that kind of assessment. It was really fun. We got to go, I went all the way to the Murray Basin area, which was towards Mildura. 4-hour drive up, 4-hour drive back. Yeah, very tiring. We went to Gippsland, went to Seymour area. I've been to Wollongong, so that was probably the most I've travelled in Victoria all my life, and it was during COVID, so yeah, that was probably the highlight of my career.
Have to skip out on all the restrictions and we were all stuck.
Yeah.
Yep. Sounds like a pretty good gig during COVID.
Yep.
Great. Well, they all sound like very, very interesting projects, and I'm sure if anyone has any questions, you guys would be happy to elaborate. Before I start answering questions from Flux, did anyone want to answer questions outright from the floor? Ask questions from the floor?
Are there any particular considerations when it comes to signalling, when it comes to high-speed rail, for example?
Sighting time. If you're doing 300k, you cannot see a signal. So that's the new systems which Colin was talking about, the in-cab signalling, ECCS or CBTC. So yeah, that is, I don't want to say cutting edge, that sounds a bit naff, but it's the latest technology which the Victorian government has endorsed, which is ECCS. Most of the new lines, it's intended that any improvement works on lines, if it's going to be an interlocking changeover, it should be ECCS compliant, so that at some point it's an easier step to upgrade the line. Yes, high speed rail, such a cool concept.
That's for regional areas
No,
for the whole.
in Melbourne as well.
Yeah.
ECCS is geared for the transition between rural and regional and metropolitan. CBTC was only really metropolitan kind of metro systems. Homogeneous rolling stock.
I do remember we were talking about how it's not really the high speedness of the train that really makes a difference in metro areas. It's more so the acceleration and deceleration times, because it's not like the amount of stations are going to decrease in metro areas. So you do want to get there as fast as you can. So it's the acceleration and deceleration that makes a bigger difference than the actual speed of the train.
It's horses for courses. So if you want to go and get more density onto the network, so what they did was with the Pakenham to Sunbury line, they've got trains closer together so you can run them quicker, and that's based around that system. But yeah, if you want to run quicker, then there's different systems that you can go through and do. Our topography in Victoria and Australia is probably the hardest thing about trying to get high-speed rail, because to try and get from Melbourne to Sydney on a flat bit of track is going to be challenging and very expensive from a civil perspective. So, but from an interlocking perspective, you look at what they've got over in Europe and in Japan and China, just the different systems and the way they do it. And from one of our perspectives is probably the driverless trains over this way, or over there versus where we can do it here. Because it'll be a challenge to get driverless trains in Victoria, but good on SRL for trying to do it.
Yeah, absolutely.
And then there was another question.
Speaking about CBTC, do you see how fast do you think the rollout would be, like in the next 50 or so years? And do you see like SRL being the next program that would have CBTC?
So CBTC is rolled out now, so it is functional on the Metro Tunnel. In terms of ETCS, we're gearing up for the ability to do it, and then I reckon SRL will have some very high benchmarks to try and roll out the next version of ETCS to be able to go through and get that through that system. It'd be interesting because it is only going to run from Cheltenham to Box Hill to start with, so it is a smaller section of the line to see the benefits of it, in my mind. But it's definitely the way of the future, and the fun part will be to see if they then roll that through all the metro lines now, because we are dealing with old circuits and things like that, but the technology will be there to be able to do it over time. And then the problem is investment from the state government. So they've invested a lot in the level crossing removal program. To then go that next step is going to take a lot more investment all that way through, but it's definitely the way it's all heading.
You said something?
No, you go.
You can go first. Sorry. You said something interesting in the answer to my question to high-speed rail. You said something very specific. You said it's technology that the government has endorsed. How are there decisions that say the government in particular in relation to signaling that you might just completely disagree with? How frequently does that occur? Is there any situation?
Can you turn off the recording?
Yeah, that is a contentious question. Realistically, the government has a pipe dream, and there's everybody else's responsibility. Hope that wasn't too
That's very well answered.
Yeah, unfortunately, the political landscape within Australia is very short-sighted, and coming back to the question over here, like the next 50 years, talking about ECCS rollouts, that's kind of how you feel the machinations of the Victorian governments and the Australian government's work. Like it takes so long to actually come up with an actual answer for any question. We're quite lucky that at the moment we're called the Signalling Strategy Task Force, and they're actually very, very experienced signaling people represented by different bodies, different organisations within the Victorian landscape, and they've put together some compelling arguments to kind of put to the Minister for Transport and say, look, this would be great, and get some endorsement. That doesn't happen very often.
Very well answered.
I guess if you've got any any further questions, you can ask outside of the room. Yes.
This may be a little bit of a less contentious in terms of legal, but maybe between you. Do each of you have like a favourite metro system around the world in terms of how they do signalling or just how it's designed?
I mean, no one's paid for me to go and test out any metro systems. So, I guess, I mean, everyone holds the Japanese system to a really gold standard. So, maybe Japanese. I think Jen wants to say something about the Japanese system.
Yeah, I did go to Yokohama for a conference, and something I noticed with Japanese systems is that you've got JR East and you've got all the metro systems, and you've got interconnecting operators. They do work very seamlessly together. I don't know how, I don't know why it's so different. Maybe you can give more insight to that. But like, you know, sharing information between different operators is very, I found that to be a thing that makes Japanese signaling the way it is. Another interesting thing is that in Japan, there was a question about level crossings. So Japan has a lot of level crossings. They had rail before they had roads. So there's a bunch of level crossings. And the question that was raised about it is like, do you worry about people, you know, damaging it, things like that? And it was just like they just didn't understand why would anyone in the public kind of do that? Why would they damage, you know, public property? And I think that goes more deep into the culture of Japan, but it was just an interesting thing. I think there's nuances, small nuances and things about culture that make the Japanese rail systems work so efficiently.
I've only experienced from afar, so I haven't seen them, I haven't delved into them, but I just hear that between what they do in Europe, not so much England, but more in Europe, between intercontinental and stuff like that, and what China and Japan do, seems to be a lot far better than what we do in Australia. Like you look at China, and this is only from what I've seen, a little bit of research, China's gone from steam trains to high-speed trains very quickly, whereas Australia, we're still running some steam trains and we haven't got a high-speed rail yet. So I think it's just, we've got so many different systems that it's hard, but yeah, it's good to see what they do in other countries and bring it in, because Australia used to be at the forefront of innovation in rail. I just think we've got a bit not that way, because we were the first ones to bring out 1500 volt DC traction for the trains, and then we haven't really tried. We just take on what everyone else has been doing. So that's why we've got ETCS now, because we think that's the best way to go. So yeah, there's definitely a lot better out there, and I'd love to go see it, but yeah, I just don't know which one's best.
I might ask one of the flux questions, just so people can be involved. So the highest voted one so far is, when I'm travelling on the train, I'm often told there are delays due to signalling faults. What are the most common faults that occur?
Anything to do with moving parts is generally a big one for faults. So, in the network, what we've got is called points. And so that's where the train diverts from one track to the other. And that's a big failure point within the network. So if one of those sets of points fails, and so with a set of points, you've got to basically lock it, detect it before a move will actually go through. So you allow a train to go through so it's safe. So if that doesn't happen, trains won't run. And so generally that's the biggest one. If a signal fails or a track circuit fails, there is a way to get the trains through with a caution order to go through, but the biggest one is a mechanical failure or a power outage. So the systems are now designed to N-1, where they can be, to keep the system going if you lose a substation. But trackside faults with points and things like that are probably the biggest ones that I've seen going through, that will go through. And projects do that as well, because we take wires out, stuff things up as we're going through to build the new ones. So you can blame us sometimes.
I remember when I was first out of my time as an apprentice, I was doing some wire tracing in Clifton Hill relay room, and I was tracing a wire to a little indication relay. It's just a little indication relay. It didn't mean much. It's just an indication. And I pulled the wire out, and that indication was indicating to the track control system that the interlocking was okay. So then the track control system said, "Oh, I've lost all communication with interlocking. We'll shut down." 20 minutes before 3 p.m.
Very popular.
Yes, that was a signalling fault. I was the signal.
I know there was a couple of people with raised hands.
What are your daily, day-to-day work like?
Mine is meetings. But that's because I'm planning to get work done. So going through for my role, it's to go through and then plan out the next job. So we're going through trying to win the next level crossing removal, which is Spotswood. So that's a lot of interface meetings, planning to work out how we're going to do it, different strategies to go through and do that. So that's my day in a nutshell, just to go through and do that part. So once you get through the construction and all that into the project management space, it's a lot of just coordination of different teams, different people, problem solving. So problem solving is probably one of the big ones to go through and do that. So that's probably my day. Yours is probably more fun.
Well, mine's spotting those tenders that keep putting out.
Yeah.
I do have a lot of meetings. At the moment, I'm finishing off assessing a cohort of graduates who are being trained through Metro Trains Academy in a graduate diploma of rail signalling and telecommunication. I think that's what it's called. So that is not as exciting as it used to be. Also, Jen implied earlier, there's a role we call checker, an independent verifier, which ensures that all the principles which we want to see in a design are captured within the design. That's my job I'm working on in my rail work at the moment. Also people management, which Culum alluded to earlier. It's not hurting cats at all.
So my day today is not like yours. I have one meeting today that got cancelled, so it's amazing. I work with a team of engineers who all work together to build to build an area of one of the QR projects. And so my day today, I just did a lot of CAD work, did my production check, which is when you've done your design and you need to check your circuits against your different analysis and all that. So a lot of it is making sure the stuff I've done is correct, so that when the checker gets it, they don't have to be like, "What is she doing?" You know, they know they can actually check the functionality of the signaling system. So that's my a lot of CAD work, a lot of Teams chats and talking to different engineers how we're going to resolve something. And not too much meetings, thankfully. I don't do too much client-facing stuff at the moment, which is a good break. But it's nice.
Sounds like a lot of communication skills in general, though, even when you're working with a team or working in meeting format. Definitely seems communication heavy.
But there is more fun than just meetings. So a lot of our site engineers, so to give you an idea of what a site engineer or project engineer goes through during the day for construction, is going through, you basically, at the start of the day, you've got your work crews that will come out. So you'll have sparkies, you'll have testers, or whatever it might be. So you're basically getting them going in the first hour to get them on site. Then you're going through and checking, go back to the office. You'll go through and check to see what they're actually doing and see if there's any queries that have come through from the team. Then you're going through, checking on, go out to them, see how they're doing and whatnot, just to make sure everything's going all right on site. And then towards the back end of the day, you're planning for the next day. So you're going through, working out what the team needs to do, what you need to coordinate. Do you need to get some materials from the warehouse? Do you need to go through and get a site prepared for them? So it's not all just about meetings. I didn't want to scare everyone too much meeting stuff, but there is from a site engineer, project engineer, and senior project engineer, there is the fun stuff of going on site and playing with the different equipment, dealing with the work crews, going through and building from that stuff. So I didn't want to just scare everyone that it's just meeting. That's just my role at the moment.
Yeah, very fair enough.
So just wondering, what software and that you guys use when you do the coordination between signals?
So that depends on the technology installed. If you're looking at the older areas, there is no software. I don't actually know where the older areas are now. That was the relays. Probably still do every line.
Yeah, there's a few out there.
But pretty much everything in use is a proprietary language. We use a system from Siemens called Westrace. We as in MGM or the Metropolitan system use Westrace, which is a computer-based interlocking, and they have their proprietary languages. When you look at the coding, it's all like a ladder logic, so it's not particularly hard to understand. There's another technology which is Smart Lock or SSI, which is one of the first CVIs created, solid state interlocking, and that uses its own language, which is quite similar to C. But that's not to say you can use C coding skills because it's, but it looks similar to C. And then there's Electrologics, which uses a form of ladder logic which looks a bit more like our relay circuits. Microlock uses Boolean, which nobody understands. And, you know, there's a whole. It's very proprietary based. So unfortunately, I can't really answer that. When we're drafting, we use MicroStation. Some operators will use AutoCAD. We don't like those operators because that's awkward. What else do we use? Otherwise, it's just your standard.
Right.
Excel, Word.
A lot of proprietary product. So each of the manufacturers has their own type of equipment, and that's unique to them. And they basically get to charge a lot of money for their designers to work on it.
Which is why we're going ETCS, because ETCS is open and theoretically anyone can do it, but not theoretically. I don't do it because you still need to be a technology provider.
Right. And they do the decision making as well.
With regards to which decisions?
So decides to whether the train keeps going or stop in the middle of the way.
The only way a train can move is if a myriad of different conditions are all true or proven to be false when they need to be false.
Right.
So if one of those conditions is an absolute and it doesn't prove to be the state it is, then the train cannot move because we cannot guarantee the safety of it. It's so heavily dependent on proving that there's no trains ahead, there's no trains moving toward the location the train is. And then we also, as part of our role, we need to account for degraded mode. Question was asked about delays and signalling faults. Yes, there will be a signalling fault, so you need to understand how your design will impact the movement of trains when there is a signalling fault. Some signalling faults you can't recover.
So the new technologies, ETCS and CTPC, how conventional signaling, and there tend to be like people who are signaling working on this.
First thing is no.
I can say from a construction perspective, fully transferable because you're building with wires. So construction, easy answer. He's got the hard one with the signal.
Yeah. So ETCS, you can run ETCS in a mode where it still uses line-side signaling. When you look at the CBTC system, which stretches from South Yarra to, I believe, South Kensington, West Footscray, something like that, there are no line-side signals. The CBTC system is designed to have absolutely no because we need to the V-line systems and the extremities of the system toward East Pakenham and Cranbourne, then yes, there are line-side signals. But I would suggest the data for the line-side signals is completely different to the data for the City Flow 650, which is the CBTC system. The skill sets, the principles are still the same, but from what I've been told, the data doesn't look anything like traditional signal data. ETCS still, as I say, you can still run line-side signals, so it would be easier, perhaps. it's still, as far as I'm aware, you still need to be part of a technology to provide the ETCS backbone, the systems. When I say a technology provider, someone like Siemens or Alstom or one of the really big technology providers that is a tier one and has the technology itself.
With the SRL being under construction, do you feel like after that's completed, would there be any differences in the signalling? For example, if there's a delays or a signalling fault on the Bennington line, would there be more leeway because people can use that to go transfer to other lines, or would it just be independent?
I don't think there's any interconnection between the two. Is there?
There will be a Clayton. Clayton will have the station there, so you can transfer passenger wise. So I think the idea is, my understanding, and I could be completely wrong here, but my understanding is the whole idea of the suburban rail loop is to create that ring similar to the ring road for cars, so you can interconnect a lot better because they want to take away from the perspective of everyone having to go into Melbourne to do all their work, and basically Melbourne's the centre. So once it eventually gets through to the airport, then you'll have a lot more options because you'll be able to, so just say the Packham line is out, you will be able to get through the SRL to the Frankston line or to the Belgrade-Lilydale line. So it is to try and alleviate that space, but also create new centres, because my understanding is for Clayton and Box Hill, they want to create more mini CBDs around that space. So it does create better connectivity. Funnily enough, we did used to have an outer ring, which ran through Deep Dean and all that kind of stuff to East Camberwell with the rail line through there back in the day. But that was many moons ago.
Our main line now?
Sorry?
No,
It's disused now.
it's a bike track.
Another line.
Yeah, so it went from Fairfield across where the Eastern is now, and then went through there. So they did have some foresight, but then no one was using it. But this is back in the 1900s. So.
And do you feel like that extra redundancy would make your job a bit easier, or would there be not much difference?
From my perspective, no difference in what we do. It creates more work for the industry, which is great. But because it's a completely unique line, so it's separated from everything else in terms of technology and everything, it actually makes our job easier because you don't have to try and interconnect interlockings and whatnot. So whenever we do a project now where we're trying to touch an old system, there's a lot of work to go into deficiencies and things like that, whereas this line will just go straight through, and similar to what they did in Sydney with the city metro. So that's a completely unique line that doesn't touch the existing, whereas here with the Metro Tunnel, we've made it touch two existing lines.
And just to follow on, from a purely business perspective, once the line's in operation, the line will have targets, just like any other line, and targets won't change because there's no line taking more passengers. Your responsibility is to run 16 trains an hour, do it or die, kind of thing. Because
Not die.
okay, maybe a bit excessive, but at the end of the day, they're not not-for-profit organisations. We're in a lease franchise, or NTM's in a lease franchise, so the big consortiums have gone in viewing it as not particularly a cash cow, but a way to generate revenue. It's not a charity. We don't have targets and not to meet them.
In terms of more, I guess, the business side of things, it seems like there's a lot of organizations and companies that are involved in kind of creating essentially not one product, but kind of one, like, roughly product. How does that kind of work of having so many companies kind of competing for the space or trying to, I don't know, like that kind of idea kind of goes?
Challenging. And there's so many different ways I can answer that question because there's different competing and different bodies as part of everything. So as Neil mentioned before, you've got Siemens, Alstom, UGL with Microlock and Hitachi going through with their different technologies. So for those, Metro has their preferences to the way they want to, which technology they want to use. One has their preference, ARTC has their preference, and then I'm sure Queensland Rail and everyone else has their own preferences as to what they use. So that's good for competition because it means that they're competing against each other to get the best technology. And to be honest, we get most of that decision making out of Europe because they all compete over there and then we just take the tail end of their works. From a construction perspective, there's so many different companies out there that are happy to go through and try and build something and then they join together to actually do that. So from where I am on Southern Program Alliance, we've got Metro, Acciona, and WSP as a designer, going through to then build and do jobs. So as Neil said, for the franchise for Metro, there's Metro's bid is done. So as of 2027, there'll be a new rail operator. But at the end of the day, not much is going to change. It's just the people that are actually the senior managers that are going to do it. So the competition's really good at the moment. In my role, it's great because then I can put designers and constructors against each other, which these guys don't want to hear, because they're going to bid for work against other contractors. But there is a lot in the market for that bidding to go through.
It was mentioned before that the new signalling systems have a higher risk of cybersecurity threats. Do you think, not sure what exactly the difference between the old ones and new ones are, do you think the benefits that it adds outweigh the risks that it could create, especially in a more technological world? Do you think it should continue into a more digital system, especially for something that can create a high risk environment?
I think it's a good question, because long gone are the days where the railways were just a closed system and you couldn't access it. With the development of the Internet of Things and massive data processing centers, we can do so much more than we could 20 years ago. We can put condition monitoring out there. We can put proprietary, like Boslow switch manufacturers might have a piece of equipment to monitor how their point machines, their switch machines are running. And it'll always upload the data to the cloud, and then it will process that data. And if MTN wants to, they can subscribe to their predictive maintenance service. So they'll say, in 3 days' time, probably need to replace this particular part before it fails. So in that way, having the ability to have a digital system should theoretically reduce the overall cost of the system, because if you're not going out there to maintain a set of points every 6 weeks, but rather only go out there 2 weeks before a fault's going to happen, then you're actually reducing the overhead of your on-site maintenance staff. So yes, it is a big risk, and it is actually something that is taken ridiculously seriously by the operators, and we want it to. But the benefits that those digital systems bring should drive down the prices of maintenance and ongoing systems. Also, at the end of the day, they're all computers, so all you have to do is unplug one Cat6 cable and plug in another one, and theoretically, it should work. It's never that easy, but theoretically, it should work.
I'll ask another one of the questions on the blocks. So, currently highest voted one is, how do you think AI will affect getting placement in signalling engineering?
Do you use AI?
We have restrictions on using AI just because of the intellectual property. So from my perspective, in construction and TNC and development in particular, we have a lot of restrictions on what we can do with AI, just due to intellectual property as well as information about the system that doesn't want to get out into the world. So similar to our document management system, it's all closed in. You've got to have access to get through it, write restrictions, all that kind of stuff. I do see benefits in AI in terms of planning and project management and so forth, but it is not, in my mind, it's not going to take away from the fact that we still have to go out there and build something. So from my perspective, AI is a tool to use, but I don't feel it's going to take away. It's only going to enhance for the moment the ability of an engineer to go through and actually try and plan and build something. As much as AI can go through and do that, it's not going to go out there and actually turn the screw and basically put everything together out there. So from my perspective, it's a tool, but it's a very moving portion. But design-wise, it's actually an interesting question.
What about you, Jen? Have you used it, AI, for your role?
Not much, only to help me with things, but I have heard it help in terms of speed up process, automate some processes like that. But no, I don't really. I think it'll take a while for it to replace your jobs or something like that.
At the moment, we are undertaking a project to see if we can get AI to complement our designers for some of their tasks, because part of the process of design is, I think Jen mentioned earlier, is the production check or the self-check for work. The problem is, you do your design and you say to yourself, I've done this design, awesome. This is the best design I have ever done. And you go through and you go, oh, done a mistake. You do all your ticks and you identify where you need to make changes, and you go through and you make the changes in the design, and then you do another production check. And you see you've missed a couple, so you go back and you do another production check. And by the third time, you're not seeing anything. You're not picking up because you've been through it so many times. It takes a weekend to come back and actually see another problem. So we're actually trying, and please tweet me, we're actually trying to develop a system where AI will complement the design of self-check. So rather than take an extra 3 or 4 days from the design process, 90% of it can be done in half an hour or an hour. I mean, it's still in its infancy. We're still writing the code to link the containers, but slightly hopeful that it will at least improve the design of our stuff. Because there's nothing worse than it being 11:30 at night when you've got a deliverable the next day. You're going, oh my god, I spelled track wrong.
I know you're not directly responsible for transit policy, but you have your own opinions about it. How do you separate those opinions from the work that you do?
By the time it gets to us, it's kind of out of our hands. We do the job.
That's true for you guys. To be honest, going through that at the moment with development and things like that as the project, at the end of the day, I joke about this with my team all the time. I wear about 3 different hats when I'm going through and doing my job. I've got my signaling hat, where I go through and I say, my signaling brain says I should be doing it. Then I've got my project hat, which is, okay, I'm part of an alliance, so we've got a deliverable to go through and, let's say, remove a crossing and do that. And then I've got my metro hat, who's my actual employer, who they have their way that they want to run the network. So it's about trying to prioritise and seeking guidance from those above me to then help guide that decision. At the end of the day, a lot of things are decision by committee these days. So to get to that point of having to decide between A and B, generally have a collective answer to go through, and it's generally based on risk. So from what we do, we go through and understand, okay, well, we can't get the perfect scenario, but what's the least risky scenario that's going to keep everyone safe to achieve the goals of whether it's the government, whether it's the project or whoever it is, even in commissioning and under construction. You just got to work out, everything we do is based on risk, because you're always going to have the potential for a train to go through into the wrong section. You try and get away from that as much as possible, but sometimes to achieve an outcome, to have 2 trains, like for instance, the safest system would be to have a network with 1 train running on it, because you're not going to have a train collision. That's not feasible. So you've got to introduce another train. The way we do that is by introducing an interlocking that then allows those 2 trains to move together. So it's all about understanding the risk and what you're trying to work through to then make that decision. So, but in terms of the higher picture, it's great that the government's investing in all these projects. It's just about how we do that and get that into practice.
Yeah. And with the level crossing routes you're working with, is there some sort of criteria you use to propose like which?
We don't propose, so that all comes from the government. So, but in doing that, they've gone through and done outcome assessments to it. Don't ask me what the outcome stands for, but it's basically the rating for every level crossing in Australia to go through it, and the government's prioritised it based on safety. So if it's got a really bad outcome rating, which says that there's been multiple incidents there and things like that, or based on congestion of the line or road traffic or rail traffic is the way that they've gone through. But they've documented those. The government's through DTP has documented all those crossings, so we don't get to make those decisions. We just have to do the work.
And then sometimes you might have the instance where there's very low risk rating at level crossing and there's a fatality, so then all of a sudden it's the highest priority.
Correct.
Definitely the worst case scenario.
Union Street in Montalban is probably the best example of that one. That was probably prioritised because there was a fatality there not long before they then kicked it in, because it obviously had an issue where someone unfortunately perished in that one. So they did bring it up the list to get it done.
I think we've got time for one more question before we go outside for some food. one. Yeah.
Hi, thank you. Because earlier you said the comparison between the new technology to the old technology is that the new technology, you also have all the signals sort of put them to the cloud.
The signals don't go to the cloud. When I was talking about the cloud, that's the health of the unit. So like a track circuit or an which is how we detect train. A point mechanism or a switch mechanism which changes trains journey from one set of tracks to another. And the signals, interlocking power supplies. These days everything can tell you if it's failing or not. So all the condition information is sent to the cloud. The signals themselves can be pumped into the driver's cab, so that all they have to do is look down and say, oh, I should be doing 40, I'm doing 110. Oops.
Alright, so the calculation is sort of done within the smart system as well. Okay. Thank you.
Okay, I think that will wrap us up for tonight then. There is food outside for everyone to enjoy. And thank you again for coming to Monash, to speaking to some prospective signalling engineers. Hopefully you guys have also gotten something out of this, and I hope the cohorts from SME, TEM and MREX have learned a bit more today as well. Great.
Thanks for having us.
Thank you very much.